In the summer of 2015, 8 Eurasian beavers were loaded into crates and driven to a dead river in Devon. That river had cost millions of pounds to manage. Dredging programs, concrete flood walls, steel barriers raised every autumn in Ottery St Mary, in Honiton, in Budleigh Salterton. The UK Environment Agency had spent years deploying the full machinery of modern flood engineering on a single 29-mile drainage ditch, and every winter, without exception, the villages downstream still flooded. By the end of this video, you will understand exactly why that happened, and why 8 animals working in the dark with nothing but mud and willow branches repaired in 3 years what a government agency could not fix in decades. What they built will change how you think about every engineered river in the world. But first, nobody planned those beavers, nobody released them, they simply appeared. The River Otter had not always been hollow. For most of the 19th century, the catchment behaved the way river systems are supposed to behave. In a wet winter, water left the channel, spread slowly across the valley floor, soaked into the marginal vegetation, and returned to the river over days and weeks. The floodplain was not a disaster zone. It was the river's storage mechanism, its biological brake. What happened across the 20th century was systematic and deliberate. Farmers straightened the channel to drain their fields faster. Landowners removed the sedge beds, the reed margins, and the willow scrub that had held the banks in place. The meandering, pocket-studded river was rationalized into a straight, steep-sided trough optimized entirely for drainage velocity. The floodplain was fenced and seeded. The oxbow lakes were pumped dry. Every structural feature that had ever slowed water down was removed. The catchment did not merely lose biodiversity, it lost its physics. A river that once spread and slowed and held water became a pipe, a high-velocity conveyor that picked up rainfall in the hills and delivered it, faster and faster, to the villages at the bottom of the valley. The Environment Agency understood this. Their engineers were not negligent. They responded rationally, deploying exactly the tools available to them: rock armor on vulnerable banks, concrete retaining structures in Ottery St Mary, aggressive annual dredging to keep the channel cross-section clear. Between 2000 and 2015, the agency spent millions of pounds of public money on the River Otter catchment. The technical reasoning behind every intervention was sound. And the flooding continued every single year, because the underlying problem was not the channel geometry. The problem was that the valley had lost 1 million years of biological infrastructure, and no amount of concrete could substitute for it. That was not a project anyone was willing to fund. Rebuilding an entire river catchment from scratch, re-establishing the marginal vegetation, the floodplain connectivity, the hundreds of small hydraulic features that had once distributed water across the valley, would have required not just money, but a complete reversal of agricultural land use across 29 miles of East Devon. It was, in practical terms, impossible. Then, sometime before 2014, beavers appeared on the River Otter. Nobody released them, nobody planned them. 2 families of Eurasian beavers, their origin never conclusively established, were spotted by a local resident and reported to the Devon Wildlife Trust. The official position of the UK government at the time was clear: wild beavers were not permitted in England. The animals were to be trapped, removed, and destroyed. Devon Wildlife Trust proposed an alternative. Rather than dismantling what was already beginning to happen on the river, they negotiated with Natural England to license the existing population as a formal 5-year scientific trial. Let the beavers stay, instrument the catchment, measure everything, then decide. Natural England approved the trial in 2015. Professor Richard Brazier, a hydrologist at the University of Exeter, took charge of the science. His team deployed flow gauges at key points along the valley, installed water quality sensors, set up a network of wildlife cameras, and began vegetation surveys across the riparian margins, assembling the most detailed ecological baseline ever constructed for a rewilding experiment on an English river. The beavers had no idea the trial had started. They began building immediately. And what those rough, low, completely inelegant structures did to the water moving through that valley was measurable within months. And completely unexpected by every hydrological model, the Environment Agency had ever applied to this catchment. It was the most closely watched river experiment in English history, and it started with 8 animals and a dead stretch of water in Devon. Not a laboratory, not a controlled research watershed managed by a government agency. A degraded agricultural drainage ditch in East Devon, written off by the engineers who had spent years trying to fix it, handed instead to 8 wild rodents who had arrived without invitation and were officially scheduled for destruction. What those 8 animals built in the months that followed did not merely surprise the scientists monitoring them. It invalidated the foundational assumptions behind decades of British flood management policy and forced a G7 government to rewrite legislation that had not been touched in 4 centuries. Before we track the physical mechanism these 8 animals unleashed on the English countryside, we need to baseline our own map. Drop a comment right now with the state, county, or province you are watching from, and tell us whether your region is currently fighting its own unmanageable flooding or river degradation. Subscribing to this channel keeps you pinned to the data as we expose the metrics the mainstream continues to ignore. Now back to the valley, because a silent catastrophe had been engineered into the very soil, and almost no one had noticed. Now here's what you need to understand about what the Environment Agency was actually trying to fix, because without it, nothing that happens next makes any sense. The flooding of Ottery St. Mary was not a weather problem. It was not a funding problem. It was not even, strictly speaking, an engineering problem. It was a physics problem that had been building for 100 years, and by the time the agency arrived with its machinery, the damage was so deep in the structure of the landscape that every intervention they deployed was, in a technical sense, already too late. A healthy river slows water down. It does this not through any single mechanism, but through hundreds of them operating simultaneously. The roughness of its banks, the drag of its marginal vegetation, the sinuous length of its meanders. The capacity of its floodplain to absorb and hold water before returning it slowly to the channel. A river with all of those features can receive a significant rainfall event and spread its response across hours, sometimes days, releasing water gradually and predictably into the lower catchment. The villages downstream do not flood because the water never arrives all at once. What the River Otter had by the late 20th century was none of that. The channel had been shortened by straightening, steepened by dredging, stripped of its vegetation, and disconnected from its floodplain. Water entering the upper catchment now moved through it in hours rather than days, accelerating as it went, arriving in the lower valley not as a gradual rise, but as a surge. The Environment Agency spent years and millions of pounds on hard flood defenses. The flooding continued. Not because the engineers were wrong, because the river had become something no hard defense could fix, a delivery system optimized, unintentionally but completely, for catastrophic downstream discharge. Tracking these layered institutional failures requires an audience that values empirical data over surface-level coverage. If that's you, hit subscribe and join our independent research collective. Now look closely at the 2014 tracking logs, because when a rogue family of animals appeared on the water, the state's first instinct was total destruction. By 2018, 3 years into the trial, Brazier's team had enough data to publish preliminary findings that stopped the scientific community in its tracks. 28 dams, built from nothing, no budget, no planning permission, no engineering survey, just instinct, applied repeatedly across a 29-mile catchment by animals that had not operated in this landscape for 400 years. 13 deep retention ponds formed where the dams had backed water into the surrounding terrain. Over 1 million litres of additional water storage held back from the lower valley by structures a child could step over. Peak flood velocities through the catchment 29% slower, total downstream flood volume down 30%. Think about that, 30%. The same stretch of river that had been flooding Ottery St. Mary every winter, despite millions of pounds of concrete infrastructure, had its flood output cut by nearly a third, at zero cost to the taxpayer, by animals working at night with mud and sticks. Not hard engineering, not state investment, not a single contractor or planning committee. Mud, sticks, instinct. But the flood data was only the first surprise, because something else was happening in the slow water behind those dams, something the flow gauges couldn't measure, and something no one on Brazier's team had predicted. But England is not the only place where a dead river has been rebuilt by an animal working at night with nothing but mud and instinct. In August 2020, the Cameron Peak fire ignited in the mountains of northern Colorado and did not stop. It burned for 3 months. When it was finally contained, 208,000 acres of Rocky Mountain forest had been reduced to ash, the largest wildfire in Colorado's recorded history, moving through terrain where federal land managers had spent decades and millions of dollars on prescribed burns, fire breaks, and forestry management programs designed specifically to prevent exactly this outcome. Every one of those interventions failed. The fire consumed them. But when researchers began mapping the burn perimeter in detail, they found something the models had not predicted and could not immediately explain. Threading through the charcoal wasteland were corridors of living green, intact riparian zones, unburned, unscorched, their vegetation standing precisely as it had before the fire arrived. The only thing those corridors had in common was that beavers had been building dams in them, unmonitored and unassisted, for decades. This confrontation between catastrophic wildfire and native biological buffers is unfolding across public lands globally. If you're watching from Colorado, California, or the Pacific Northwest, tell us in the comments whether local land managers are using nature-based wetlands for fire prevention. Your field reports keep our mapping accurate. Now look at the final invoice for this regulatory paradigm shift, because the numbers are staggering. None of this had been planned in 2015, when 2 families of unauthorized animals were discovered in a Devon drainage ditch and scheduled for destruction. The final invoice reads as follows: 8 animals, 28 dams, 13 ponds, 1 million liters of water held back, flood peaks down 30%, 400 years of absence ended, and in Colorado, green corridors standing intact inside 208,000 acres of ash, because beavers had been quietly saturating the landscape for decades while the forestry programs around them burned. The question is no longer whether nature-based systems can outperform capital-intensive engineering. The evidence on that is settled. The question is why we keep building the concrete. If the foundational logic of modern flood management, that rivers must be controlled, straightened, accelerated, and contained, is not merely ineffective but actively catastrophic, then every dredging program, every flood wall, every dollar and pound spent hardening the landscape against water is not a solution. It is the problem, compounding itself at public expense, year after year, flood after flood. What other multi-million-dollar land management industries are we funding while pretending to fix the crises they cause? Drop your thoughts below alongside your location, and if this investigation changed how you see environmental data, subscribe to Earth Discovery Series. Because in our next file, we travel to the sawgrass swamps of South Florida, where fewer than 30 wild panthers remained on Earth, every kitten born with heart defects and curled spines, and a 95% extinction probability was sitting in a government computer, until an elderly Texas lion hunter was quietly ordered to put 8 female mountain lions on commercial flights and release them into the Everglades. What happened next makes everything in this video look like a warm-up. 8 beavers fixed what millions of pounds could not. They did it in the dark, in the rain, with mud and sticks, following an instinct 400 years older than the problem they solved.